Assalamu alaikum, good morning, namaste, sat sri akal, buenos dias. My name is Raja Salim Akhtar. Welcome in this new video. The Frenet-Serret Theorem. Arc derivative of the tangent binormal and principal normal are simply normal unit vectors denoted by dt unit vector over ds or t unit vector derivative, db unit vector over ds or b unit vector derivative, and dn unit vector over ds or n unit vector derivative, such that first formula t dash is equal to kappa n curvature. Second formula b dash is equal to minus torsion tau n unit vector. Third formula n unit vector derivative is equal to tau b unit vector minus kappa t unit vector. These formulas are formulae are known as Serret Frenet formulae. Proof. Number 1, we know that t unit vector dot t unit vector equal to 1. Differentiating with respect to arc length s t unit vector dot dt over ds plus dt unit vector over ds dot t unit vector, derivative of 1 is equal to 0. This implies 2t dot dt over ds equal to 0. This implies t dot dt over ds equal to 0. If dot product of two vectors is 0, then the vectors are perpendicular to each other. This implies dt unit vector over ds perpendicular to t unit vector, but dt unit vector over ds equal to r double dash, and the equation of osculating plane at a point P on a curve is r vector minus small r vector, r dash vector, r triple dash vector in scalar triple product bracket notation equal to 0, with comma or without comma. I use commas in this notation. All the 3 points are coplanar, so this implies r double derivative is equal to dt unit vector over ds lies in the osculating plane. Therefore, if it lies in the osculating plane, therefore dt over ds also perpendicular to b unit vector along the binormal. Hence, dt unit vector over ds perpendicular to t unit vector, and dt unit vector over ds perpendicular to b unit vector. As you prove above, this is perpendicular to t, here this is perpendicular to b. Then if it is perpendicular to t and b, hence we get dt unit vector over ds will be parallel to b unit vector cross t unit vector. B unit vector cross t unit vector equal to n unit vector, so it can be written as dt unit vector over ds parallel to n unit vector, b unit vector cross t unit vector equal to n unit vector. So if two vectors are parallel, a vector parallel to b vector, then a is equal to kb. From vector analysis you know that this implies dt unit vector over ds equal to plus minus kappa n unit vector, proportional to make equal, because dt unit vector over dt magnitude is equal to kappa curvature and kappa is always positive, plus minus kappa, as curvature kappa is also always positive. Therefore dt unit vector over ds equal to kappa n. This is the first formula, or t unit vector derivative is equal to kappa n. Proof of the second formula. We know that b unit vector dot b unit vector is equal to 1. Differentiating remember it. Differentiating with respect to arc length s db unit vector over ds b unit vector plus b unit vector dot db unit vector over ds, derivative of 1 is equal to 0. This implies 2b dot db over ds is equal to 0. This implies b unit vector dot db over ds equal to 0. This implies dot product of two vectors is 0, then the vectors are perpendicular. This implies db over ds perpendicular to b unit vector. It means db over ds lies in osculating plane. Also b dot t unit vector equal to 0. Differentiating with respect to arc length s db unit vector over ds dot t unit vector plus b unit vector dot dt over ds is equal to 0. Using the first formula, dt over ds equal to kappa n unit vector. This implies db unit vector ds into t unit vector plus b dot kappa n unit vector equal to 0. Using dt unit vector over ds is equal to kappa n, first formula. This implies db over ds dot t unit vector plus 0 equal to 0 because b dot n unit vector is equal to 0. This implies db unit vector over ds dot t unit vector is equal to 0. This implies db dot ds is perpendicular to t unit vector. Hence dB over ds perpendicular to b unit vector and dBu over ds, dB unit vector over ds perpendicular to the unit vector implies dB unit vector over ds parallel to b cross t unit vector. But b cross t unit vector is equal to n unit vector, db unit vector over ds parallel to n unit vector, because b cross t is equal to n unit vector. This implies dp unit vector over ds equal to plus minus tau n unit vector. Tau is the torsion, because dB unit vector over ds magnitude equal to torsion plus minus t. As torsion tau is negative, therefore dB unit vector over ds equal to minus tau n unit vector. This is the second formula, or b unit vector dash is equal to minus tau n unit vector. Now we prove the third formula. Number 3. We know that n unit vector is equal to b cross t unit vector. Differentiating with respect to arc length s, dn over ds dn over ds equal to, apply formula, db unit vector over ds cross t unit vector plus b unit vector cross dt unit vector over ds. Using the formulas, dt over ds equal to kappa n unit vector and dB over ds equal to minus tau torsion n unit vector. We get dn unit vector over ds equal to dB over ds minus tau n unit vector cross t unit vector plus b unit vector cross dt over ds is equal to kappa n unit vector. Tau and kappa are scalar. N cross t is equal to S. N cross t is equal to minus b unit vector b cross n. Here b cross n unit vector equal to minus t, clockwise direction in the circular form. This implies dn unit vector over ds is equal to minus tau into minus b unit vector plus kappa into b cross n minus t unit vector. This implies dn over ds equal to tau b unit vector minus kappa t unit vector. This is the third Serret-Frenet formula as required, or n unit vector dash is equal to tau b unit vector minus kappa t unit vector. Remember also.